Eye operations require the use of fine ophthalmic instruments, which demand special standards of processing. Most importantly, these processes must subscribe to the most exacting of safety standards. This subject has recently attracted a great deal of attention against the backdrop of discussions on measures to prevent the iatrogenic spread of TSEs or variant CJD. The cleaning of instruments in a washer disinfector in an alkaline wash solution is said by experts in the field to reduce the risk of cross-contamination. Ophthalmic instruments used in modern operations are extremely delicate and highly sensitive. Consequently, they must be processed with utmost care. Take the phaco handle, for example, one of the more critical instruments. Such instruments often feature very fine suction and irrigation channels with narrow lumens, which pose cleaning and disinfection challenges. Alongside the correct cleaning aspect, safeguarding the value of ophthalmic instruments and the compatibility of the cleaning process are both very important issues. In view of the deficiencies of manual reprocessing, which was often the method of choice in the past as it was seen to cause less damage to instruments, there is now no longer any way around validatable machine-based cleaning and disinfection. Processing instruments in a washer disinfector can reliably eliminate the risks associated with manual washing using chemical disinfectants. The disadvantages of manual processing include the risk of spectrum gaps, microbial resistance, changes in concentration caused by the breakdown of active ingredients as a result of the protein effect, risks to personnel through the allergenic or toxic properties of chemicals. Unlike manual methods, machine-based cleaning and disinfection can both be standardized and validated. The Vario washing and disinfection program ensures the safe, thorough but gentle cleaning of ophthalmic instruments. This modern approach is based on a standardized process. The program cycle begins with a cold pre-wash aimed at removing the majority of blood and proteinaceous debris. This is followed by a gentle main wash at a temperature of 55 degrees Celsius, maintained for 5 minutes. The preferred product in this phase is an alkaline detergent. In order to bring alkalinity levels back down again, the main wash is followed by citric acid neutralization, followed by 2 interim rinses. This concatenation of program phases ensures that there is no carryover of detergent or neutralizing agent into the final rinse, eliminating the risk of eye burns in subsequent operations. Thermal disinfection occurs in the last rinse cycle at a temperature of over 90 degrees Celsius with an exposure time of 5 minutes. This phase of the program uses fully demineralized water in order to avoid even the slightest traces of residue on the instruments. The final drying phase involves drying the outer surfaces of the instruments using hot air. Internal drying, as explained later, is a subsequent manual process. In order to expose the fine, delicate and often very lightweight instruments to mechanical and spray action, silicone rubber receptacles are required to secure the instruments in mesh trays. This prevents jostling and damage by the force of the water jets. This also allows mesh trays to be configured to individual requirements. The receptacles are designed to ensure minimum points of contact so as to allow water to flow off freely. End stoppers are also required on straight instruments to prevent longitudinal movement. Alternatively, inserts are available, allowing instruments to be secured in plastic retainer strips. Up to 4 inserts can be used on one level. Gentle cleaning is predominantly attributable to a mechanical approach specifically geared to ophthalmic instruments and using the cleansing power of water. The impact of the jets of water from the lower spray arm is softened by the use of a perforated steel plate, which also prevents instruments from being pushed upwards. The water jets from the upper spray arm and an additional spray arm attached to the basket ensure thorough cleaning of instruments from above. This also presses instruments into their retainers and ensures that they are securely held for the duration of the wash. A powerful circulation pump enables even the narrowest of lumens and internal orifices to be properly irrigated, washed and disinfected. This is achieved by connecting hollow instruments to the water circulation system. In the case of extremely narrow cannulae, such as Sauter hydrodissection cannulae, rinse water passes through special ceramic filters in order to prevent narrow lumens from being blocked by particles. At the end of eye operations, instruments are collected and placed in a transfer container for reprocessing. Here a mesh tray awaits with a customized arrangement of silicon receptacles and stoppers to suit the instruments used. The first instruments to be positioned are the colibri forceps. Scissors, too, are held securely in place during reprocessing. The same applies to the lid clamp, which is inserted in a predetermined position. All instruments, as in this case the wire lid retractors, are held in place by the silicon receptacles so as to ensure that they are not dislodged by the force of the water. Stoppers are used to ensure that straight instruments, like the ones here, can't slide lengthwise. Forceps are secured in their open state to make sure that water accesses the jaws from all sides. The receptacles should always be arranged in such a way as to prevent contact between instruments. They are designed to ensure minimum contact to guarantee full access to all surfaces. The sharp blades of diamond knives are particularly delicate. They are cleaned in a secured position with the blade extracted to ensure good exposure to water. Once all the instruments have been arranged, the mesh tray is placed in the washer disinfector. The machine is able to accommodate 4 mesh trays with 4 OP sets. The upper level contains connections for lumened instruments and the intricate cannulae from 4 eye surgery sets. Each of these instruments is connected individually to the water circuit. This ensures sufficient and thorough exposure to the wash liquor during reprocessing. Clogging of very intricate cannulae through circulated particulate soil is prevented by the use of filters. When cleaning multi-lumened instruments, each individual lumen must be connected to the water circuit to ensure adequate irrigation. And finally, the phaco handpiece is secured in the appropriate receptacles and connected. Four complete cataract surgery sets, as in this case, can be cleaned and gently reprocessed in the Miele thermal disinfector. Central instrument reprocessing in a CSSD environment allows ophthalmic operating sets to be processed together with instruments from other disciplines in large barrier washer disinfectors. If this approach is adopted, it's important that the mesh trays with ophthalmic instruments are placed onto the upper level of the mobile injector units, and that the force of the lower water jets is weakened by placing an additional perforated plate below the mesh trays. In this array, various narrow-lumened instruments can be connected to the row of nozzles at the side. As the instruments are dried on the outside but not on the inside, narrow-lumened instruments are dried after cleaning and disinfection using compressed air. This method also serves as a test of lumen patency. Spraying the residual water from the instrument ducts onto indicator paper and monitoring the pH value provides a simultaneous method of identifying residual alkalinity. Machine-based instrument reprocessing in conjunction with alkaline detergents was introduced to our hospital about a year ago in order to provide our patients with the highest possible degree of infection control, to comply with the pertinent national regulations and to embrace the recommendations of the Robert Koch Institute. In our experience, this system has produced first-class, hygienic, safe and economic results.